Hey everybody. I wanted to go through and walk you through the solutions to the first mock exam that I posted. The answer key is posted on Canvas already. I'm just going to go through and talk through it here and kind of annotate and show you where in the questions I'm pulling answers and things like that. I've already had one person request a Zoom to kind of go through this with me, and so if you're in that same boat, I'm happy to do that. I do want to reiterate what I said in the directions on Canvas. I do not expect you to be able to do this in 50 minutes. All right, question one, you will have, whatever the equivalent is, you will have 25 minutes in which to finish the question, and then 5 minutes after that to upload your answer. And then question two will be 15 minutes with 5 minutes to upload. So for these, you need to know that you will not finish the entire question. That also means it might be worth the time to read the whole thing and kind of go, oh, I know how to do A, B, C, and F. Let me do those first, and then I'll double back to D and E. So just as a suggestion to throw that out there. Okay, so for this first one, we're talking about drought in Southern California. So they were required to restrict how often they ran water to their lawns. And as a result, some of the trees in the city died because they didn't have enough water. Concerned citizen decides to take a sample in order to measure the number of dying trees. He uses a city map that divides the residential homes into several thousand blocks. He randomly selects 75 blocks, and of each of those 75 blocks, he counts the number of dead trees. Here's a histogram of his data, along with the summary statistics. Each bin in the histogram has a width of 2. So the first bin contains all the blocks that had 0 or 1 dead tree on it. The next one would be 2 and 3 trees, and then so on. All right, so I do think this is indicative of what you would get in that they give you the summary statistics already and they give you the graph. One of the things they said in Tuesday night's webinar is you will not be required to generate a data display. You will not have to generate a graph. So that's great. It sounds like everything they're going to ask you to do has to be either numerical or verbal. Like it has to be something you can type on a keyboard, which makes sense. So they're not going to ask you to try to do a dot plot on a Word document. That's just not going to happen. So predictably, when we get a question like this, the first thing they're asking us to do is to describe the distribution. All right, so when we're talking about distribution, remember that's our SOX or our VSCO. And you need to make sure that you are mentioning outliers. I'm sorry, not outliers. We'll get to outliers. Context. So it's not enough to just say the center is here, it's skewed to the left, whatever. You have to give units. Somewhere in there, in one of those four, you need to say what the context is, what the heck you're talking about. So in this case, we're talking about number of dead trees. So you would need to reference that at least once in going through your distribution. All right, so this is his answer key, the guy that created this. Distribution of the number of dead trees is skewed to the right and has a center around 1. One thing I would recommend that you clarify is when you're doing this, if this was yours, I would say what measure of center you're using. I would say it has a median of 1, or it has a mean of 2.36. So be explicitly clear, don't just say center. I don't think that's sufficient. And in that case, you could have done either one. You could have done mean or you could have done median. If they don't give you one of them, use the one they give you. If they don't give you one, but they do give you the total number of your sample size, your N, you can work backwards to find your medians. You know that there's, 80 trees that they were talking about. You know your median has to be between the 40th and the 41st. So you can use a histogram to estimate that. If they give you it, you just go ahead and spit it right back out at them. Okay? Most of the data is from 0 to 4 dead trees. So remember, when we're talking about this, we're talking about shape, outlier, center, and spread. So the spread, they're addressing spread by saying most of the data is from 0 to 4 trees, and you could do that. You could also say that it has a range of from 0 to 16 trees. That would be an accurate answer as well. You could say most of the data is between 0 and 10 with an outlier somewhere between 15 and 16. And that covers both of those. I'm sorry, 14 and 15, not 15 and 16. All right, the way he's recommending that it would be scored is if you mentioned all 5 of those things, your SOX or your VSCO plus context. If you mentioned all of those, you would get full credit on that one. If you only did 3 or 4, you get partially correct. You get a P. I would expect to see this. I would expect to see a SOX or VSCO question. Honestly, on the first one, I feel like that's something that they would do to kind of ease you into it. Everybody should be consistent with that. I would expect to see something like that. A data display like this, I would really expect. Okay, interpret the sample standard deviation in context. Again, they're not going to ask you to calculate the standard deviation because they said you can do this without a calculator. So you're not doing standard deviations by hand. So that is not something that you would have to generate on your own. They might give you this and ask you to interpret. So we've been doing that all year. In this situation, we've got the number of dead trees per block differs from the mean of 2.36 by 2.88 trees. So we want to say what it's differing by and what it's differing from. So I've got context in there because I'm talking about number of dead trees per block. I'm showing the distance from the mean. And yeah, that's it. Pretty quick, pretty easy, simple sentence. They might ask you to, I would expect to see a standard deviation. I think that's something that will pop up, like to interpret. I think that's something that would be an easy kind of checkbox to go through and do. All right, so this is top of the next page. Name the sampling method used by this citizen to estimate the number of dead trees per each block, not home. That's a typo. I'm sorry if that messed you up. Okay, described by this method of randomly selecting blocks was a more practical choice compared to using a simple random sample of homes. All right, so there's 2 things in here they're asking you to do. First, you have to say what the sampling measure is, the sampling method is, and then you have to say why it's practical, which means you've got to say why it's good and why an SRS would not be good. You have to give a positive and a negative. All right, so let's back up for a second and go back up to the original problem. So we're here. It said he randomly selects 75 blocks, and for each of those 75 blocks, he counts the number of dead trees on each block. All right, so when you choose by location, that's going to be your cluster sample. So he has picked those, each block counts as a cluster, and out of the several thousand blocks, he picked 75. So those and on those 75, he surveyed all the dead trees. If he wanted to do stratified random sampling, he could have picked from, if he took those blocks, and then he could have subdivided them by socioeconomic status, by soil type, all the different kinds of things like that, and then picked from each one of those, then that would be stratified random sampling. All right, so we're talking about a cluster sample, and then the second part of that question says, what's the advantage versus disadvantage? All right, so for the advantage for this, it's going to be easier. It's convenient. He can look at one block and get all of the trees. If he did an SRS, he would have to look at one tree all over the place, and that's just not convenient. All right, so if you had all 3 of those, you would get your full credit. All right, this is where I started hearing from people was the probability, which I'm not surprised. It's been a minute. We did probability before Thanksgiving. So yeah, it's been a minute, and when we did it, it was still a little stressful. So if you're looking for resources, go back and look at Chapter 5. That's where all this probability stuff is. You have an extremely detailed one sheet from Chapter 5. So go back and look at those if you're looking at the formulas. And if your one sheets are a hot mess, either print out new copies and redo them, or write it in a way that's more organized for you because you get to use them. So I would expect a probability question like this, but I would also expect a probability question that you can quickly look up. I'm going to go ahead and say this one, letter D, I think you might get. Letter E, I would be concerned about because they're saying you can do it without a calculator. I'm not trying to do that fraction to the fourth power without a calculator. To me, that seems a bit much. So they might be asking you slightly different ones. All right, so let's look at this one. It said, estimate the probability that a randomly selected block in the city will have less than 6 trees. All right, so the probability that that randomly selected block will have less than 6 dead trees, it's the probability that you would have 0 or 1 dead trees, plus the probability that you would have 2 or 3 dead trees, plus the probability that you would have 4 or 5 dead trees. These numbers here, the top of those fractions, are how tall those histogram bars are. So, sorry if I make you dizzy. Scrolling back over here. Oops. Sorry, y'all. Alright, so for this one, the writer was assuming this was 52, that this was 8. I think they did 5 for that one. If they're going to give it to you like this with such a wide scale on the y-axis, they're going to be very flexible with what they accept. They would probably take 51, they would probably take 53, 55 for the first bar. For the second bar, I would expect them to take anywhere from 7 to 9, that those would be fine. And then an equivalent for the third one, probably like 4 to 7, as long as you are within the right ballpark. As long as you didn't say that the second bar was bigger than 10, I think you'd be fine. As long as you didn't say the first bar was smaller than 50, you'd be fine. And then when we were doing the actual calculations, what we're looking at here is each of these are being divided by 75 because it was the 75 clusters. And when you add all those up, you end up with 0.867 or 86.7%. You can write it in decimal form or you can write it as a percent. It's totally fine. It's just it's a preference. It doesn't matter. All right. In theory, they are going to want to see your work. That being said, I don't know. They have, we don't have scores for these. So I would expect if you at least wrote this part, you would be fine. This leaves no doubt that you know what you're doing, but I think the second 2 rows would be sufficient. At the very least, you want to write the second row because if you messed up doing your math, if when you were adding those like on a 4-function calculator, something like that, and you did it in your head incorrectly, if you show your work, they can still give you credit. All right, so then jumping down to letter E. It says we'll assume each block is independent of the next, and that's a huge thing for our probability. We've got formulas based on independent events, and that's what this is referencing. So given that 19 of the city blocks had no dead trees, what's the estimated probability that if 4 city blocks were chosen, these blocks would have at least 1 dead tree? All right, so we had 4 formulas. So probability of all, probability of none, probability of at least 1, and went through all of those. So again, that's in your one sheet from chapter 5. So definitely go back and take a look at that. But the formula for that is, for the probability of at least 1, is 1 minus the probability of none. And then that n is the number of times you're pulling. So in this case, we're talking about 4 city blocks. Oops, sorry, I'm not still on the highlighter. So we're talking about 4 city blocks. They tell us that 19 of the city blocks had no dead trees. So the probability of none is that 19 over 75. So it's 1 minus 19 over 75 to the 4th power. You want to do that exponent before you do the subtraction. There's not parentheses around that. And so when you work that all the way out, you end up getting 0.998 or 98.8%. All right, so if you forgot the 1 minus, you'd get partial credit. So making sure you've got that. All right, for letter F, for further analysis, the concerned citizen is considering creating a 95% confidence interval to estimate the average number of dead trees. Are the conditions satisfied for inference? Explain why or why not. All right, so they give you 2 hints. They tell you T confidence interval, and then they say average number. So they are referencing a mean confidence interval, a mean significance test, which is slightly different conditions than a proportion. So first, we want to make sure that it's random, and it was. They said he chose 75 random blocks with a random sample. We want to check our 10%, and 75 is less than 10% of several thousand, which is what they said. And then for when we're doing approximately normal for means, there are 3 things. So first would be the easy way, where they would tell us it was normal. They didn't. The second would be as if it passes the central limit theorem, which means the sample size is bigger than 30. And in this case, it is. The last one is if you draw out your dot plot and it is shows no obvious skew or outliers. But put a pin in that for a second. About 5 minutes ago, I told you that they said they weren't going to make you draw any graphs. So if they're not going to make you draw any graphs, odds are it's not going to get to that point that you won't have to make a dot plot or a histogram to look at. All right. So in this case, you've done all 3 of the conditions. It's met all 3 conditions. So yes, the conditions are satisfied for inference. So again, one of the things we've talked about off and on this course is making sure that you're answering the question that's asked. So you might say, if you were rushing, you might go through and list the 3 conditions, but then not actually say, yes, it passes all 3 of those conditions. So make sure that you're taking that time to go back and read the question and make sure you're actually answering what's being asked. All right, cool. So that was the first one. That is my expectation. I would guess that's about the ballpark for a 25-minute question. For the next part, it should go a little quicker. The second one should be shorter, and in this case it is. All right, so for this one, we're talking about researchers were curious if different regions of the country differed in their use of a new popular social media app. So 2 independent random samples were taken. 1 sample from a city on the west coast of America and another from the east coast. College students aged 18 to 25 were asked if they have used the app. Their responses are organized in a table and a graph below. All right, so we've got a 2-way table. Then we've got our mosaic plot over here showing all of our information. Actually, I'm going to take that back. No, that is a mosaic plot. I think there. Hang on, I'm measuring. No, I lied, it's not. So remember, a mosaic plot is wider or narrower based on the sample size. It gives that extra information. And my eyes were playing tricks on me. It looked like those bars were a little wider than they actually were. Okay, so first thing it's asking is, does there appear to be an association between which coast a student is from and whether or not they have used the social media app? Note, do not answer this question using an inference procedure. Basically, they're not asking you to make a test. They're just saying, hey, just look at the numbers and what do you think? All right, so if you're a West Coast person and you've used the app, that's 123 over 221. If you're an East Coast person and use the app, that's 270 out of 423. All right, so when you start crunching those numbers, the East Coast students are a little more likely to have used the app than West Coast students. So if you look over here, this East Coast relative to that bar is a little taller. Is it a big difference? No. It's 63.8 to 55.7. So there is a real valid case to be made to say, no, there's not an association because those numbers are too close together. So as long as you say that, you're fine. And that's exactly what they're saying here on the underscoring. All right, letter B. What's the probability that a randomly selected student is from the West Coast given that the student has used the social media app? Ooh, the dreaded given formula. All right, so I wrote this out down here for you. It's the probability that the student's from the West Coast given that they said yes. All right, so probability that they're from the West Coast and yes is that 123. And then the total number of yeses is 393. So that's where our fraction's coming from. So west over yes. So that ends up being 0.313. So it's about 1/3. All right, and then again, this is how I would expect to see inference addressed. Like they did in the first question, they might ask you about conditions. They might ask you to just write your hypotheses. They also, like they do in Part D, ask you to interpret a p-value. I think that's as much as they're going to ask you to do. I think asking you to do a full significance test just is not feasible because they're going to want to be addressing more than one standard. So in this one, it says, curious statistics student wants to test out if the proportion of students who have used the app is greater on the East Coast than on the West Coast. Write the appropriate null and alternative hypotheses for this hypothesis test. All right, so for the null, I've got PE minus PW, and that would equal 0, because the null hypothesis would be that there is no change. There is no difference between the two. Second one is saying that they're saying it's greater on the East Coast than on the West Coast. So if you were doing your subtraction, East Coast minus West Coast would give you a positive number, and so it has to be greater than 0. Make sure somewhere in here that you label. We did P1 and P2. That is totally fine. But somewhere in your answer, you need to say what P1 and P2 are. So P1 is East Coast, P2 is West Coast. If you wanted to use letter subscripts, that's totally fine. You just, again, have to label, so they're not mind readers. They need to know exactly what you mean. All right. Letter D. P-value for the hypothesis test is 0.002. Oh, I said that wrong. 0.022. Based on this p-value, what conclusions should the researcher make? So we're going to assume that we are using an alpha of 0.05 because they didn't tell us any different. If they give us a different alpha, then obviously use that one. But since they didn't say anything, we're going to assume 0.05. 0.22 is smaller than 0.05, so we can reject our null hypothesis, and we do have convincing. He used the words statistically significant evidence. Convincing evidence works just as well. That the percentage of East Coast students who have used this app is greater than the percentage of West Coast students who have used this app. Okay, so that works. It's pretty straightforward. I would expect to see something like that. I am very sure that they are going to want to make sure that you know how to look at a p-value. So expect that. Letter E. Another study, college students on the East Coast were compared with 85 students in the Midwest, and a p-value of 0.13 was found. However, there is a concern that a type 2 error has been made. Describe how a different sample size would increase the likelihood of a type 2 error. So if they used a larger sample size is lower your risk of a type 2 error. Again, if you need to go back and look at that, that is, we talk about it a little bit in 8.1 and 8.2, and then we come back to it in 8.3. And if you go back and look at the notes for power, for 9.3 is where it comes up. So if you go back and look at the notes for power, we go into type 1 and type 2 errors in pretty significant detail there. And what we find is that if you, like I said, if you increase your sample size, your probability of a type 2 error decreases. So this, if you look at the sample size, they were comparing, what, in the hundreds? Yeah, so the East Coast was 423. They're comparing that to 85 students. So that is a much smaller sample size, which is going to raise the possibility of a type 2 error. All right, so there we go. So I'm going to put up another one of these on Friday for you, and I'm just going to keep doing that each week. get at it when you can. I am well aware that your other classes are throwing final things at you. As usual, the deadlines for me are flexible. They're there to try to give you a target to hit, but if you need an extra day or two, that's totally fine. A bunch of you emailed me today saying you couldn't quite get there, and that is all right. And then the other thing I want to point out is, again, part of what I'm giving you these is for you to start to get used to that time frame. So make sure when you're doing these that you're keeping an eye on the clock. Look for a video from me, like I said in my email, coming out soon about the different nitty-gritty for testing. I hope you guys are doing well. I miss you. I'm looking forward to maybe seeing you Friday night. Take care of yourselves. Bye.